So, good afternoon, everybody. I hope I'm audible. Can somebody confirm that I'm audible and my screen is visible? Can somebody unmute and confirm that I'm audible?
Yes, sir.
Yeah, okay. My screen is visible. Screen
Yes,
is
sir.
visible.
Yes, visible.
Okay. Thank you. So let us start. So basically, we are dealing with presently the chapter number 6, that is combustion in CI engines. And in the previous lecture, we have reached up to the different stages. Once again, revise and then proceed. So basically, what we are dealing with this in this particular chapter is the combustion in CI engine. And when we talk of a CI engine, it is a bit different from SI engines. Even though the combustion process is very similar, wherever you go, the combustion process is basically oxidation reaction. So the fuel is oxidized with the help of oxidant. So we have fuel and oxidant, which is oxidized to give carbon dioxide and water with elevation of some amount of heat. This is a combustion process. In order to ensure the combustion in CI engines, some basic requirements has to be confirmed or satisfied. First being requirement of hot air in the combustion chamber, which in turn requires the use of higher compression ratio of the value above 16:1 in case of CI engines. Then we require some fuel injection system, which comprise of a fuel injection pump and a fuel injector and some other parts, which ensures the fuel is injected in the required format or required form, which is in the form of the droplets of proper size, and that results in a preparation of a heterogeneous mixture. And since the mixture is heterogeneous, that is where the requirement of CI type of combustion is coming into picture, which we have discussed in detail in the previous lecture. Then, in order to sustain the combustion in the combustion chamber, the proper type of combustion chamber and proper type of injector has to be selected. So some parameters need to be controlled for ensuring sustained combustion in the combustion chamber. Then we have to ensure that all the air supplied to the combustion chamber and all the fuel supplied to the chamber is going to be used optimally. And for that, we need to control the injection duration, rate of injection, and air motion. So all these things has to be ensured. So how the normal combustion happens in CI engine? Here we are having a compression ignition engine, which means we have a heterogeneous mixture, which is burned in the CI mode, that is compression ignition mode, and therefore called as CI engines. And in order to ensure this, initially air is taken into the combustion chamber during suction stroke. Compressed charge is then ensured that the temperature increases above self-ignition temperature of the fuel, fuel is injected at the end when the air is having sufficient enough temperature, higher temperature, then we go for injection of the fuel in the small droplet format, and we ensure that the fuel is distributed in the combustion chamber in a good manner, even though we say that is a heterogeneous mixture. And every fuel is supposed to burn independently. So we said the burning of droplets, the scenario is something like burning of, sorry, the cracking of the crackers being bursting in the sky on a Diwali day, early morning. So that is where that scenario is, which is completely different from that of a SI engine, where in SI engine we have a spark plug at one end and a spark being developed at the spark plug, and that particular flame spark is being developed into a full-fledged flame, and that flame is traveling across the combustion chamber. Here it is completely different. Here every droplet is burning independently. So one corner one droplet may burn, other corner other droplet may burn. There is no uniformity in the burning. Any droplet may burn any time. Some may burn early, some may burn late. So there is no uniformity in that. And to ensure that the proper droplets are going to burn completely, we have to ensure that air motion is going to be imparted to the air inside the combustion chamber. So different types of air motions are there, like swirls, squish, etc. And these motions are supposed to be imparted to the air to ensure that proper air fuel mixture is being formed and proper burning is happening inside the combustion chamber. And to ensure that the power generated is as per requirement, we need to control some parameter, and the parameter we need to control in case of CI engine is injection duration. So when we want more power, we increase the injection duration so that more fuel is going to be injected into the combustion chamber and more power is going to be produced. When the power required is lesser, then the fuel injection duration will be kept smaller, and therefore the fuel introduced into the combustion chamber is going to be smaller, and therefore power produced is going to be lesser. And all this particular combustion process happens in 4 different stages. Unlike in SI engine, we had 3 stages. Here we have 4 stages. And that is how a normal combustion happens. And in the diagram, we have shown a P theta diagram, pressure crank angle diagram for a CI engine combustion. Now the different stages. So these were a point which we were discussing. So we have 4 different stages: A to B, B to C, C to D, and after D. So A to B was the ignition delay, B to C was the rapid combustion or uncontrolled combustion, C to D is the controlled combustion, and finally we have after D, which we call as after burning stage. So A to B. So this is a list of the stages, the different stages in SI engine combustion, where ignition lag, flame propagation stage, and after burning. And here we have the different stages as ignition delay, uncontrolled combustion stage or rapid controlled combustion stage, and third one is the controlled combustion stage, and fourth one is after burning. So you should not confuse with each other. Very clear distinction is there, clear difference is there between the 2 combustion processes. So you have to keep this in mind when you are writing the answer for the questions. And the question can be explained with a neat diagram, the process of combustion in case of CI engine, or with a neat sketch explain the P theta diagram for CI engine combustion, or question may be explain the different stages of combustion in case of CI engine. So whatever the question, the answer is going to be the same. So first we have to talk of the combustion, then we have to talk of normal combustion, then we have to list the different stages, and then we have to go for explaining each stage. So now let us start with the first stage. So the first stage is the ignition delay period. So the first stage in SI engine combustion was ignition lag. We called it as ignition lag. Here we are calling it as a ignition delay. Now the word delay is coming into picture because basically here we have the fuel being introduced into the combustion chamber in the form of droplets. Unlike in SI engine, we had prepared the mixture outside the combustion chamber and supplied to the engine cylinder. We are here directly injecting the fuel droplets into the combustion chamber. So the mixture has to be formed inside the combustion chamber. Okay, and therefore whatever is related to the burning of the fuel and the preparation stage before that, you have to be happen, all these things has to be happen inside the combustion chamber, and this happens when in the ignition delay period. Okay, so the first, this stage is between A and B. What is A? A is the point where the injection starts, fuel injection starts. So fuel injection is going to start at point A. The instant when we inject, it will not burn, because we know that for burning the fuel, some mixture has to be formed. Then the mixture has to be within the inflammability limit, that is neither too rich nor too lean, where it can burn. And since the fuel is going to burn with due to self ignition, the mixture temperature has to go above self ignition temperature of the fuel. So these things has to happen. So once you inject the fuel here, two things are happening. First is the mixture formation, because we have injected the fuel in the form of liquid droplets. So this liquid droplets has to be converted into air fuel mixture. Now it is droplet suspended in the air. It is not a mixture. We want air fuel vapor mixture to burn. Isn't it? So the mixture has to form, and then the ignition will happen. So the ignition of the droplet here, we are speaking, when we are talking of ignition here, we are speaking of ignition of the droplet. Okay, ignition means basically starting of the combustion. Here that is the meaning. So the mixture formation stage is also called as a physical delay, and the ignition is called as chemical delay period. Okay, now why this is called as a physical delay period? Because some physical things are happening in this particular stage. What are all those things which are happening in this particular stage? So the physical things which are happening are, fuel is atomized. So when we inject, it is in the form of droplets. Is it going? So the flow is coming out through the hole of the injector, but after coming out, it is being broken up into small droplets, which we call as atomization. So atomization, then every droplet is going to vaporize. So as we have discussed earlier, the fuel droplet can be considered as a sphere of a liquid. Okay, and the outer surface of the sphere is now exposed to hot air. Now this hot air will supply heat to the surface layer of the fuel. So what happens is, some physical things are now going to happen on the periphery of the droplet, on the upper surface of the droplet. So what all things are going to happen? The liquid fuel, that is fuel molecules from the liquid fuel droplet is going to diffuse out, trying to diffuse out into the air. From the air molecules are going to diffuse into the fuel. Okay, so when this is going to happen, we have here the formation of a mixture on the surface of the droplet. So the droplet is basically liquid. Okay, basically it is liquid, and this around this particular liquid, on the surface of the liquid, we have vapor, layer of vapor. So you can imagine now one liquid droplet. Surrounding that liquid droplet, we have a vapor blanket of vapor, cover or blanket of vapor. Okay, inside of which is liquid, surface is vapor, air fuel vapor mixture, and outside is air. Correct? So three things are there. So here we have a droplet. Okay, and outer surface here, or outer layer. So inside this is liquid, here it is liquid, here it is air fuel mixture, and here it is air, purely air. So the three different things in the three different regions. Here it is completely liquid, so fuel in the liquid form. Here it is air fuel mixture, air and fuel mixture, and here it is only air, because air is trying to diffuse in, liquid is trying to, or fuel is trying to diffuse out, and therefore in this region you are getting a layer of, or a blanket of, or a cover of air fuel mixture. Okay, so fuel is atomized, so the fuel on the surface is atomized, sorry, fuel is being atomized when the fuel comes in from the nozzle hole. Then the droplet is going to vaporize, so here the vapor is going to form, it is going to mix with air. So in order to form vapor, it has to absorb heat. So first it will be absorbing heat, correct? Then and then only it is going to vaporize. So here it is going to absorb heat. Heat is being absorbed. Air molecules are going to diffuse in. Fuel molecules are going to diffuse out. The mixture is going to form. Air fuel mixture is going to form. And this particular mixture will reach self-ignition temperature of the fuel. This will reach self-ignition temperature of the fuel. So all these things are going to happen during physical delay period. So since all these things are physical things happening, okay, we call this as a physical delay period. So till now, remember, nothing chemical has happened. No chemical reaction has happened. Only one thing is moving to other side, other thing is moving to this side, and such things are happening. All the physical things are happening, and therefore we call this a stage as a first stage or first substage of a delay period as ignition delay period. So this small d is your physical delay period. This particular period is this A to B. So here from A to B, okay, and this is being subdivided into D and E. Okay, so D and E. So this is your D, that is physical delay. So it is a mixing period, which we call as a physical delay, and E is your interaction period or chemical reaction period, and therefore chemical delay. Okay, so physical delay and chemical delay, and during physical delay we have chemical reaction period, and during chemical reaction period we have interaction period. Okay, so physical delay and chemical delay. And during physical delay we have interaction period, and during interaction period we have chemical reaction period. Okay, so physical delay and chemical delay. And during physical delay we have interaction period, and during interaction period we have chemical reaction period. Okay, So somewhere here it starts burning in this particular layer in the blanket. So and that flame will now propagate throughout the surface of the droplet. So now this becomes like a burning fireball. Burning fireball. Okay. So this is something like a burning fireball now. This from outside. Now in SI engine, how was the flame traveling? The flame was traveling. We had a combustion chamber. So we had a combustion chamber. Here somewhere the droplet was, spark was ignited. The flame was traveling like this toward the combustion chamber in SI engine. So this was in SI engine. Correct? This was in SI engine. But now we are talking of CI engine. Here the droplet is burning from outside and the flame will travel from the outside, that is the surface of the droplet, to the center of the droplet. Okay. So the chemical reaction starts and the droplet starts burning. So it's not completely burned, it just starts burning. Okay. And when it just starts burning, it starts liberating some amount of heat. And when it starts liberating some amount of heat, the temperature and pressure starts rising. And that is the point B where the pressure and temperature just starts rising, and therefore the combustion curve departs from your motoring curve. And therefore our first stage of combustion, which we call as ignition delay, is from A to B, where A is the point of the fuel starting of the fuel injection, and B is the point where the combustion curve departs from motoring curve, or we call it as a start of combustion. Okay. So remember, here we are talking of, we are used the word combustion. Okay, starting of combustion, but here we are saying of ignition. Okay, here in the second stage we are talking of ignition, that is start of burning is ignition and actual burning is combustion. Okay, so that is where the two stages are there: physical delay, chemical delay. During physical delay, fuel is atomized, vaporized, mixture is formed, and the mixture reaches self-ignition temperature. During chemical delay period, chemical reaction starts and the droplet is engulfed by the fire. Okay, engulfed by the fire, and it starts burning. So this is what happens in the first stage of combustion, which we call as ignition delay period. So I hope everybody understood what is happening in the first stage of combustion, which we call as ignition delay period. So many times the question is asked in the combustion in the examination, explain the ignition delay in case of CI engine. Then you have to explain all these things. Okay, you have to draw the PT diagram, whatever has been shown. You have to mark the point A and B. Then you have to say that the point, what is point A, what is point B. Then you have to say that it is being subdivided into two parts, two periods, and you have to name this particular two periods, the physical delay period and chemical delay period. Then you have to explain what is happening in the physical delay period, what is happening in the chemical delay period, and finally you can say, yes, this is your ignition delay period. Okay, so what is ignition delay? The period between the starting of injection to starting of combustion. This is your ignition delay in case of CI engine. It has two sub periods: physical delay period and chemical delay period. During physical delay period, fuel is atomized, vaporized, mixture is formed, and the mixture reaches self-ignition temperature. During chemical reaction period, the chemical reaction starts and the droplet starts burning. Okay, so this is about first stage of combustion. So I hope everybody has understood the first stage, and let us move on to second stage of combustion. So next is second stage of combustion, that is your B2C. So second stage of combustion is called as uncontrolled combustion stage or rapid combustion stage. So the name is rapid combustion stage or uncontrolled combustion stage. What is point B? Point B is the point at which the combustion is supposed to start, or we can say when the combustion curve departs from motoring curve. So B is the end of ignition delay period. So it is a B is the end of ignition delay period where the beginning of combustion starts. Okay, and C is the point when the pressure is maximum pressure is attained in the combustion chamber. Whatever the maximum pressure was supposed to be attained in the combustion chamber, that is being attained. Okay, so the period in between B to C, that is starting of combustion and the point at which the maximum pressure is attained in the combustion, C, in between these 2 points, we have what we call as a second stage of combustion, which we call as rapid combustion stage or uncontrolled combustion stage. Rapid combustion stage, RAPID, rapid, or uncontrolled combustion stage. Now, what is rapid? Rapid means faster. Rapid means faster. What is uncontrolled? Means it cannot be controlled. There is no control over it. So, as the name indicates, there is no control on what is going to happen, at what rate is the combustion is going to happen in this particular stage of combustion. And that is why it is called as rapid combustion. That is why it is called as rapid combustion. Okay. So now why it is uncontrolled? Let us see. What happens in this stage basically? Suddenly all the accumulated fuel droplets are going to auto ignite. So you have started injection at point A and you are going on spraying the droplets. So as you move from A to B, you are going on injecting the fuel droplets into the combustion chamber. Injection is going on. Injection is going on. So the droplets are going to be accumulated in the combustion chamber. Okay. But they are not actually burning. They are not actually burning. Ignition has started during chemical delay period, but they are not actually burning. When they are going to burn, combustion starts here. Combustion starts here. So here, whatever fuels are being accumulated, म्हणजे आतापर्यंत बी पॉइंट पर्यंत जे काय फ्युएल साठलेले आहेत कंबशन चेंबर मध्ये, whatever fuels are droplets are accumulated, they are going to auto ignite. Suddenly they are going to ignite. आपण बघा फटाकेला काडीनं किंवा उदबत्तीनं त्याला पेटवतो, परंतु ते लगेच पेटत नाही. सुरुवातीला थोडंसं फुसफुस फुसफुस फुस करतं आणि परत अचानक फट्ट दिशेनं फुटतं. सडनली ऑटो इग्नाइट. सडनली ऑटो इग्नाइट. मग जे काय whatever the fuel droplets were accumulated in the combustion chamber were suddenly going to auto ignite. Suddenly going to auto ignite. Suddenly going to auto ignite. Almost 1/3 heat is liberated in this stage. How much heat is going to liberate? Out of the total heat liberated throughout the combustion, all the 4 stages, 1/3 of the heat is going to be liberated in this stage. 1/3, almost 1/3, or rather more than 1/3. Okay. So the temperature and pressure suddenly goes on and reaches very high, because at the end of this stage, we are going to have maximum pressure, correspondingly almost maximum temperature also. Okay, so pressure and temperature are related to each other, correct? So when we attain the maximum pressure, simultaneously, preferably simultaneously, we'll get the maximum temperature also. So when we get the maximum pressure, preferably we get maximum temperature also. So some here and there, but obviously we can say this almost at same point. So temperature and pressure reaches very high, goes on very high this particular stage. All the accumulated droplets are going to burn. Here we are talking of auto ignition, but here we are saying all the accumulated fuel is going to burn. आतापर्यंत जे काय ड्रॉपलेट साचलेले होते ते सगळे बर्न होणार अचानक. आणि कसं झालं? ऑटो इग्नाइट, एक्सप्लोजन, स्फोट. अचानक स्फोट झाला. अचानक जसं फटाके पहिल्यांदा फुसफुस करताना परत अचानक ठो म्हणून फुटतं. सिमिलरली हियर ऑल द ड्रॉपलेट्स विच हॅव accumulated, जे काही साठलेले ड्रॉपलेट्स होते ते सगळे अचानक ठो म्हणून फुटणार. आणि त्याच्यामुळे काय झालं? सडनली लॉट ऑफ हीट इज लिबरेटेड, सडनली लॉट ऑफ प्रेशर इज बीइंग इन्क्रीज्ड, and we say we don't have any control on rate of pressure rise or rate of temperature rise. maximum pressure is attained. Pressure goes on increasing and maximum pressure is attained. जी काय मॅक्झिमम प्रेशर अटेंड होणार होतं, पोहोचणार होतं, तिथपर्यंत पोहोचतंय ती, या स्टेज मध्येच पोहोचतंय. This is what happens in the uncontrolled period of CI engine combustion. काय होतंय? फर्स्ट स्टेज मध्ये काय झालं, त्याच्यावर अवलंबून आहे सेकंड स्टेज. फर्स्ट स्टेज मध्ये काय झालं, ड्रॉपलेट्स कंबशन चेंबर मध्ये आल्या, त्या प्रत्येक ड्रॉपलेटच्या बाहेर काहीतरी फिजिकल गोष्टी झाल्या, त्याच्यानंतर काहीतरी केमिकल गोष्टी झाल्या आणि ती बर्न व्हायला लागलं. आता चुलीमध्ये लाकूड टाकलं आपण, त्याला कागदाचा बोळा टाकला, आता ते लाकूड पेटायला लागलं. फक्त पेटायला लागलं, अजून पेटलेलं नाहीये पूर्ण, सुरुवात झाली. इग्निशन हॅज स्टार्टेड व्हेन इन द फर्स्ट स्टेज. म्हणजे लाकडं भरपूर आहेत, ती पेटायला लागलेत आता. सो ड्रॉपलेट्स आर देअर अँड दे आर इग्नाइटेड. नाव at B, what happens? Combustion starts. And how the combustion starts? How the combustion happens? Suddenly all the fuel accumulated in the combustion chamber, suddenly all the fuel droplets accumulated in the combustion chamber auto ignite, auto explosion, स्फोट होतोय सगळ्यांचा. अचानक सगळ्या ड्रॉपलेट्सचा स्फोट होतोय. The temperature and pressure rises rapidly, suddenly. काय होतंय, टेम्परेचर वाढली, प्रेशर पण वाढलं, खूप वाढलं. किती वाढलं, मॅक्झिमम पर्यंत जाऊन पोहोचलं. ऑल द अक्युमुलेटेड ड्रॉपलेट्स बर्न. आतापर्यंत जी काय ड्रॉपलेट्स अक्युमुलेट केले होते आतमध्ये, जे काय आतापर्यंत आलेले होते, ते सगळे बर्न झाले. and maximum pressure is attained at point C. आता जी काही फ्युअल ड्रॉपलेट आपल्याकडे होते, तुमचा कर्व ए टू बी असा चाललाय. ही तुमची पॉइंट बी आहे, बरोबर. ही पॉइंट बी आहे, ही पॉइंट ए आहे, ही पॉइंट ए आहे. आता ही लाईन जी आहे ही अशी जाईल, अशी जाऊ शकते, अशी जाऊ शकते, अशी जाऊ शकते, अशी जाऊ शकते. आता ही सी इथपर्यंत आहे का, इथं आहे का, इथं आहे का, इथं आहे का, ही कोण ठरवणार? हू इज गोइंग टू? वी डोंट हॅव ए कंट्रोल. जर या स्टेज मध्ये कमी नंबर ऑफ ड्रॉपलेट साठलेले असतील तर ही कर्व असं जाणार. थोडेसे जास्त साठलेलं असेल तर असं जाणार, अजून जास्त साठलेलं असेल तर ते असं जाणार, अजून जास्त साठलेलं असेल तर असं जाणार, आणि अजून जास्त साठलेलं असेल तर असं जाणार. सो ऑटो इग्निशन इज गोइंग टू, the amount of auto ignition is going to depend on what is the number of droplets accumulated, fuel droplets accumulated in the combustion chamber during first stage of combustion. पहिल्या स्टेज मध्ये जी काही फ्युअल अक्युमुलेट झालंय ते सेकंड स्टेज मध्ये बर्न होतंय. आणि ती कसं बर्न होतंय? ऑटो इग्नाइट, सडन एक्सप्लोजन, स्फोटच होतो एकदम. मग ती जर जास्त फ्युअल असेल तर मोठा स्फोट होणार, आणि कमी फ्युअल असेल तर बारका स्फोट होणार. मग बारका स्फोट झाला, द कर्व विल गो लाईक दिस. मोठा स्फोट झाला, इट विल गो लाईक दिस. सो द पॉइंट सी कॅन बी हियर, हियर, हियर. हाऊ इट इज मूव्हिंग अप, we are not in control of that. Why? It depends on how much fuel is going to accumulated in the point in the period A to B, and therefore it is called as uncontrolled combustion period or rapid रिएक्शन्स झाले, जे काही कंडिशन्स होते, टेम्परेचर किती वाढलं, कॉम्प्रेशन रेशो किती होता, इनलेट एअर टेम्परेचर किती होतं, त्याच्या हिशोबाने